All right, welcome. Ever stop to think about how a program, actually keeps track of a whole bunch of things at once? Think about it like you're packing for a trip. You've got different bags for different kinds of items, right? Well, Python does pretty much the same thing, just with what we can call digital containers to keep all its data organized. So let's dive in and unpack how they really work.
So, yeah, this is the big question. If you've got a list of names or maybe a set of map coordinates or even the steps in a process, you can't just have them floating around randomly. You need a solid way to group them up, to keep them in order, and to grab them whenever you need them.
And Python's answer to this whole problem is what it calls sequence types. It's a simple idea, really. A sequence is just a collection of items that has a specific order. We're going to take a look at the three main workhorses here: lists, tuples, and the super efficient range object. To really get a handle on this, we're going to use an analogy for each one. First, we'll look at the flexible shopping list, which is perfect for understanding lists. Then, the unchanging recipe for tuples, and the efficient number generator for ranges. After that, we'll pull it all together to help you figure out which one to use and when. Okay, first up, the list. Honestly, the best way to think about a Python list is just like a shopping list you'd scribble down on a piece of paper. It's meant to be changed, right? You add items, you cross things off, maybe you even change your mind about something entirely. And that brings us to this really key term, mutable. It sounds kind of fancy, but all it means is changeable. Once you've created a list, you're totally free to mess with it however you want. And that flexibility? That's its greatest strength. Let's see what this actually looks like. Here, we're making a list called groceries. We just use square brackets and separate our items with commas. That's it. We now have our little container, and inside it are bread and eggs. Oh, but wait, we forgot to get milk. No big deal. With a list, we can just use this handy append method to stick milk right on the end. See? Our list just grew, and our data is updated. It's that easy. But what if you change your mind? Say you want bagels instead of bread. Well, we can target that very first item, which in programming is always at what we call index 0, and just assign a new value to it. This is what we mean by mutability. We're changing the contents right there on the spot without having to create a whole new list. Now let's switch gears and look at a totally different kind of container, the tuple. So if a list is our flexible, changeable shopping list, a tuple is more like a recipe that's been printed in a cookbook. The steps are fixed for a reason. You're supposed to follow them exactly as they're written. No changes allowed. And this brings us to the complete opposite of mutable, immutable. It just means unchangeable. Once you create a tuple, that's it. Its contents are locked in. You can't add things, you can't remove things, you can't change things. Now, this might sound like a weakness, but you'll see it's actually a super important feature. So making a tuple looks a lot like making a list. But notice the key difference. We're using parentheses this time, not square brackets. So we've defined our three recipe steps. It's still an ordered sequence, just like a list, but that one tiny difference in the brackets, well, it changes everything. So let's put this unchangeable rule to the test. What happens if we try to swap out the first step of our recipe, just like we swapped bread for bagels in our list? We'll use the exact same syntax, trying to assign a new value to that item at index 0. And nope. Python immediately stops us with a type error. It's basically saying, hey, you can't do that. A tuple object doesn't support item assignment. This isn't a bug, it is 100% a feature. The immutability of that tuple is protecting our data, making sure it can't be changed by accident. The recipe is safe. So why on earth would you want something to be unchangeable? Well, this quote from the official documentation gives us a huge clue. Because a tuple can't be changed, Python knows it's stable. It has a permanent identity. And that stability means you can use tuples in special places, like as a key in a dictionary, something you absolutely cannot do with a changeable list. All right, let's meet our third and final sequence type, range. Now, this one's a little different. It's a real specialist, and it's designed for one main job, creating a sequence of numbers as efficiently as possible. I want you to think about it like this. If you needed to count 1,000,000 steps, you wouldn't actually write down every single number from 1 to 1,000,000, would you? Of course not. You just remember where to start, where to end, and maybe the size of each step. That is exactly what range does. It doesn't store all the numbers, it just stores the recipe for making them. And this right here is its superpower. It doesn't matter if you need a sequence of 3 numbers or 3 times billion numbers. The range object itself barely takes up any memory at all.
It just needs to remember the start, the stop, and the step. This makes it incredibly, unbelievably efficient. So, the most common place you're going to see range is inside a for loop. When you write range of 3, you're basically telling the loop, hey, I need you to do something 3 times. The range object then dishes out the numbers one by one. First, it gives the loop a 0, then on the next pass, it gives it a 1, and on the final pass, it gives it a 2, and then it stops. It generates the numbers only when they're needed. So efficient.
Okay, let's bring it all home. We've met our 3 sequence types. Now for the really important part. How do you pick the right one for the job? Well, it all boils down to what you actually need to do with your data. This little table pretty much sums it all up. If you need a collection that's going to change, adding, removing, or swapping things, you want a list, our flexible shopping list. If you've got fixed data that should never, ever be altered, you go with a tuple, our unchanging recipe. And if all you're doing is generating a sequence of numbers, especially for loops, range is your specialized memory-saving tool.
So I'll leave you with a question to chew on. Think about these real-world examples. A list of top video game scores that's always changing, a set of fixed GPS coordinates for a specific map location, or just the numbered aisles in a huge warehouse. Which container would you pick for each one and why? Because picking the right container, it's not just a technical detail. It really changes how your program works with its data.